Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at how to simplify radical terms. All right, so the instructions for the examples we're going to do are for us to simplify the following terms. All right, so for question number 1, let's say we have the radical fourth root of 112 x to the third y to the eighth. All right, so to simplify that completely, so the solution is as follows. So what's the simplified form of the fourth root of 112 x to the third y to the eighth? Well, to simplify this, we need to pay close attention to the index of the radical. Okay, the index of the radical basically tells us exactly how to simplify. So the index here in this particular problem is 4. Okay, so that's the index of the radical. So something to note is that the index tells us the number of repetitions of a factor in order to be able to break out. Okay, it tells us the number of repetitions of a factor to break out. All right, what are we breaking out of? We're going to break out of the radical. All right, so some terms will have the power to break out of the radicand position, and some will not have the power, but the index tells us how many. So in this case, since this is a fourth root, in order for a term to be able to break out of the radical, it has to have a power of 4. Every factor that has a power of 4 can come out as a fourth root. Okay, all right, so let's go ahead and do this. So in order to determine if any of these terms, so this is y to the 8, has a power that's sufficient, or a number of repetitions and factors that's sufficient to break out of this radical position, we're going to decompose this term completely, break it down completely, and then examine the factors, okay? Now, when you're breaking down numbers, you want to use primes. Only use primes to break down your numbers. That's the best way to avoid making mistakes. So your prime numbers are the numbers that are divisible by just themselves and 1. So we have the first prime is 2. Prime numbers are 2, 3, 5, 7, 11, and then it goes on and on. Okay, so let's take a look at 112. Since it's even, we know that the prime number 2 goes into it, so we can extract 2 from 112. So 2 goes into 112 56 times, so 56 x to the third y to the eighth. And then this is still even, so we can still take out another 2, factor out another 2, and then that gives us 28 x to the third. When you're factoring out prime numbers, you know for sure that you're not leaving out anything, because that's the smallest possible factor that can go into that term, right? Okay, so now this is still even. Take out another prime, 2, namely 2 goes into 28 14 times. And then this is still even. Take out another 2. 2 goes into 14 7 times. And then 7 is prime. You see that? So we can't break 7 any further. So let's break down the variable terms. So this is x to the third. Means you multiply x by itself 3 times, 3 repetitions in the factor. Y to the eighth means you have 8 y's multiplied by themselves. 1, 2, 3, 4, 5, 6, 7, 8. Like that. Okay? All right, so we talked about this earlier. The index is 4. Okay, the index is 4, so any term that repeats itself 4 times is a fourth power, and we can take the fourth root of that to just one of the factors. Okay, so for the 2's, you notice that, let's see, we have 1, 2, 3, 4. That's a fourth power. Okay, so we can group them together. That's 2 to the fourth And this 4 repetitions right here can break out of the radical as 2, because the 4th root of 2 to the 4th is 2. So let's do that right here. The 4th root of 2 to the 4th power is just simply 2. It's just 2, because the inverse operation is the 4th power of 2. These two cancel out. That's the whole idea. Okay? The 7, on the other hand, doesn't have the power to break out, so it's going to stay behind. Okay, 7 stays behind. Let's box it. And then x, oh, that was so close. There's only 3 of them, so those stay behind too. Let's box the ones that stay behind. And then the y's, we have 1, 2, 3, 4. Okay, that first group of 4 y's multiplied together. 1, 2, 3, 4. They can break out. That's y to the 4th. That breaks out as a y. Okay? And then we have another 1, 2, 3, 4. Oh, excellent. That's another 4th power y to the 4th. That breaks out as a y. Okay? Because the 4th root of y to the 4th, these are inverse operations. They cancel out. And then that's just simply y. All right? So let's see what the final answer looks like. So what comes out? The numbers that come out are 2 and y. So this is going to become 2 times the first y that broke out times the second y that broke out times the 4th root of everything that stays behind, which is 7 times x times x times x. So just put this all back together. 2 times y is 2y squared times the 4th root of 7x to the 3rd. Bam, like that. And there goes your final answer for question number 1. All right, let's take a look at another example. For number 2, let's say we have the term, the 3rd root of 216 x to the 4th, y to the 4th. Okay, so our goal is to simplify this term. Let's go ahead and simplify that. Okay, so don't forget the index tells us the number of times a factor should repeat in order to be able to break out of the radical position. All right, so in this situation we have the 3rd root of 216 x to the 4th, y to the 4th. Do you see what the index is here? Do you see what the index is? In this particular problem, the index is 3. Okay? This is the index right here. The index is 3. So every 3 repetitions of a factor or 3rd power, you can take the 3rd root of that, and that will come out as one of the factors. Okay? So the index is 3. So the rule for this particular example is the 3rd root of any number, let's say x to the 3rd. For instance, is just going to be x, because when the index and the power matches, it's like an inverse operation. Another way to think about this is, using the properties of exponents, the 3rd root of x to the 3rd is the same thing as x to the 3rd raised to the 1/3, right? And when we multiply that together, you get x to the 3 over 3. So the powers cancel out, and you end up with x. So this is just showing you using the properties of exponents. All right, so that's a side point. So let's go ahead and break down 216. Remember, we're using our prime numbers. So since this is even, 2 goes, that's the smallest prime that goes into it. So take out 2. 2 goes into 216 108 times. And then this is still even. Take out another 2. 2 goes there 54 times. That's even. We can take out another 2. 2 goes there 27 times. All right, now it's odd. 2 doesn't go anymore. The next prime number is 3. All right, 3 goes there definitely. 3 goes here 9 times. And then 3 goes into 9 3 times. All right, and then you have 4 x's, 1, 2, 3, 4. and for y's 1, 2, 3, 4. Okay, so remember the index is 3, so we're looking for groups of 3 repetitions in any identical factor. So for the 2's, notice we have 1, 2, 3. That's 2 to the third power, or 8. The cube root of that is just 2. So this will break out as a 2 of the radical, okay? And then we have 3 3's here, so that's another power of 3. Okay, this is 3 to the third power, or 27. The cube root of that is just 3, so that will break out as 3. Down. And then for the variables, 1, 2, 3, the first 3 x's, x, 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 breaks out as x. And then this one stays behind because it doesn't have the power to break out. Okay, so this one stays behind. And then if you look at the y situation, the first 3, 1, 2, 3, these 3 can break out as a y. Okay. All right. So what is our final answer going to be? Let's put it together. So the simplified form is going to be 2 broke out, 2, another 3 broke out times 3, an x broke out, and a y broke out. And then the radical component, terms that didn't break out because they didn't have enough power, is x times, let's box this y right here, bam, bam, x times y. So the final answer, it's simplified form, 2 times 3 times x times y is 6xy times the third root of xy. Okay, so that is the final answer for question number 2. All right, so we're going to give you some problems to try out to demonstrate mastery of these concepts that we just went over. Remember, if you have any questions, just put it in the comment section below, and we'll be glad to assist you. All right, so here are some practice problems for you to try out. All right, go ahead and try them out, and then we're going to be showing you the answers in a few seconds. All right, so there goes the answer to questions 1 to 4. All right, so let us know how well you did in the comment section below. Thanks again for watching, and we'll see you in the next video. Goodbye.